Welcome to the Faculty Forum Online, where MIT alumni get to interact with MIT faculty around their research and timely topics. I'm Judy Cole, the Alumni Association Executive Vice President and CEO, and I'll be the moderator. To participate in today's webcast, input a username and your location, and then type your question at the bottom of your screen. We won't be able to get to every question that comes in, but we'll try and get to as many as possible. Today's guest is Andrew Whittle, the head of MIT's Department of Civil and Environmental Engineering, also an alumnus, and he himself is a geotechnical engineer. Professor Whittle, thank you for joining us. Our theme today is the threat of coastal flooding and what protective means can we employ against it. Could you begin by telling us something about the nature of the threat?
I think the main threat are the big storm systems, mainly the tropical storm systems coming from the Atlantic, which affect all of the Gulf of Mexico and the east coast of the US. They're the ones we're primarily concerned with. So Sandy's a good example, Katrina in New Orleans a few years ago. I think what has been spectacular in both those two particular storms was the very large storm surge that they generated. And the storm surge is essentially the rise in mean sea level that's occurring. A certain amount is because of the pressure reduction in the center of the eye of the storm, and then you get a lot from the currents, the setup essentially of the wind field. And what's interesting, and we saw this in Sandy, it's not the absolute wind speed which controls it, it's the extent of the wind field and the path this thing takes, and then of course the topography of the coastline and the bathymetry offshore the coast, which determines how large the surge is. But in Katrina, we saw probably the largest surge in the US, which was in some places as much as 30 feet or 10 meters.
Wow.
And in the case of Sandy, of course, it was something in the order of 14, 15 feet around Battery Point, down at Battery Park, down at the tip of Manhattan. So that's the main element. And you can add to it the fact that sea level is rising, and we know that that's occurring at a much slower rate, but we might expect another 3 foot of sea level rise by the end of this century. So that will, of course, add to the effect of the storm surge. And then I think most critically, the mechanism that as the temperature of the sea increases in the tropical areas, the potential for more intense storms has appeared. And I think this is something our colleague, Kerry Emanuel and his group over in the EAPS department have demonstrated rather effectively. And of course, you combine those together, and we really are facing a situation where big coastal flooding events are likely to be more frequent over the next century. So,
and does lunar cycles affect the storm surge as well? Sure,
the astronomical tides. If you connect one of these events into an astronomical high tide, that of course adds to this too.
Yeah.
And of course that also affects the prediction, because the prediction of a surge is linked to the modeling of these storm systems and of course the weather patterns that underlie them. So, but we've got much better at predicting. As you saw in Sandy, we had reasonable advance notice of the storm, and the system was able to shut down and so forth.
So what lessons can we learn from other high population density coastal cities that have done a better job of this than we have?
I don't know if you want to say they've done a better job. I think it's taken singular events, singular storm events, to motivate lots of other places. In where I come from in the UK, the 1953 storm is really what generated all of the storm system protection works in the UK and the Netherlands, what's become known as the Delta Works. And that started essentially in 1953, but the build-out wasn't completed until just a few years ago. If you take the equivalent in New Orleans, the events, I think it was Hurricane Betsy in 1965 was what initiated the need for hurricane protection systems in New Orleans. But if you think about that, it was 2005 and we still didn't have a complete hurricane protection system for New Orleans. And
so does that mean we're starting over from scratch now after Katrina? Did it wipe out the work that had been done before?
Post-Katrina, it's completely been rebuilt. I mean, if you diagnose the situation on the hurricane protections in New Orleans, although they started planning the systems in 1965, the gestation time, the time for designing these systems, is really very long. So they didn't get approval for building the system until about 1992. So that's a long period of time. And then they got themselves in this protracted cycle of construction where funding, the project was always underfunded. So that by the time Katrina hit, they were already 5 years late on delivery, and there was an expectation of at least another 12 years of construction because the funding was so poor. Post-Katrina, of course, they put, $15 billion into this thing, and they've completely rebuilt and hardened the system, made it more resilient. They've built it to the specs that they had anticipated in 1992, and they've done more. They've built mobile gate barriers for the Inner Harbor Navigation Canal. So in New Orleans, they've done the right thing, but after the event. And the question is, what do you do in New York City? We had a warning in, there was an evacuation last year, and then we've had Sandy this year, and the question is, does a big city like New York need some more direct action now?
When we were chatting before this broadcast, you were talking about flood insurance and how much that actually costs the federal government.
Yes.
And I did not know about it, and so I think our viewers would be interested.
This is a really important issue because none of the private insurance companies will offer flood insurance by and large. So the U.S. government is kind of the insurer of last resort. So they run, essentially the federal government runs an insurance scheme for flooding. And it's not a very good insurance scheme. It actually costs the tax. We take in a certain amount of money from the homeowners, but in fact we pay out a lot more. So we're actually very far in debt on that insurance scheme. And the extraordinary thing about it is the scale of it is so large. It's tens of billions of dollars overdrawn after Katrina alone, for instance. And so we're spending a lot of money on paying homeowners to build in risky places, where we could take that same money and we could do something much more effective with it if we turned around and made a national infrastructure strategy rather than trying to pander to tastes of individual homeowners and so on. And so national flood insurance is individually very popular, politically very popular, but very expensive for the federal government. So that is a big hidden story in the costs of doing business.
It seems, and this is sort of related to that whole strategic question about how we choose to invest our money, whether in the insurance or in the big projects. It seems that the U.S. has been reluctant to take on mega engineering projects for the past decade or more. Why do you think they're taking this approach?
Well, I think the big ticket up front is a big part of the problem, but it's the political willpower to recognize strategic assets that are at stake. I mean, to come back to that North Sea flood in 1953, it did take the UK government quite a time to sort of perceive how critical the risk from storm surge would be in London. But when they did, they were able to mobilize and get the funding in place very quickly. I think they started building that somewhere in the mid-70s, and it took maybe 5 or 6 years. But like the US, population growth is still in coastal areas. They now have a big exposed population outside of the zone protected by the barrier, and it's now forcing them to look at new designs. So, it's a continuing challenge. So coastal flood protection is a moving target, and, worrying about the 100-year timeline, the risk of a similar flood to Sandy is probably at a sort of 1 in 100-year event, but as sea level rise occurs, that could be a 1 in 20-year or 1 in 10-year event.
As Mayor Blumberg said, we've had, what?
Right. So
several 100-year events in 3 years in a row.
Right.
So
which is statistically possible, of course, yes.
Let me take some of the alumni questions. Yolanta in Miami asks, how would you compare the success of the Dutch system of dikes that have been constructed over centuries and the most recent multi-decade effort that was completed in the 1990s with the U.S. Army Corps of Engineers works around New Orleans?
Well, the Dutch, obviously, as she says, has a tremendous history of dike protection. They're like in New Orleans, a lot of the land's below sea level. The Delta Works is actually very interesting because the Delta Works actually is, I think, something like 17 separate projects that were built over an extended period of time. And the Dutch were amongst the first to run into the challenge of building big coastal infrastructure to sort of be, how should we say, environmentally sensitive. I mean, a lot of the systems that were proposed originally were simply barriers, and we're going to shut off large inlets from the sea. And it took a fair amount of persuasion, even in the Dutch situation, to move to more environmentally benign mobile gate systems, which only closed on limited periods of time. But you can see that the Dutch have had a very long-term view of this, and of course it's a national threat to them. It is, I mean, I think more than 1,000 lives were lost in the storm in '53. It was devastating.
Wow.
It devastated a large fraction of the country. So, you know, I suppose you'd have to turn around and say, Katrina has been the wake-up call for New Orleans. The US government has responded in the same way the Dutch government. So I'm not sure that, you know, one would hold up one government as better than the other. But it's very clear that the long design cycle of these coastal works is because of the very big impacts they're having on environments. And so it's taken that kind of effort.
I wonder if part of the challenge for the US also has to do with the fact that significant portions of our population don't live near a coast, whereas in Holland, pretty much everyone is going to be affected to some greater or lesser degree.
Right, but that's why I say a much more strategic view is needed. I mean, New Orleans, for example, isn't just a city of 500,000 or whatever the current population is. I mean, it is also a major port for the Mississippi. It is also a major refining area for petroleum products and so on. And you know, as a consequence of Katrina, you shut down the port, you interfered the refining. It affected the whole country. I mean, there's a much more strategic element there than just defending a population of 500,000, say. So there are other issues, and I don't think the federal government has taken a very proactive role. I think a lot of this is left to the states, and of course the states may not have the kind of money for some of these works. So.
Frank in Honolulu asks an excellent question. Given rising sea levels and the prediction of more severe storms, shouldn't the coastal strategy for the long term include backing away from the coast in high-risk areas?
Well, this is what I was trying to say about the national flood insurance. I mean, you know, I don't think we build big cities in high-risk areas. We have cities on the coast, but it's much more the local development patterns and the lack of regulation that enables people to build in high-risk areas. And the fact that the government will insure, I think, is a big problem. So, you know, we want to provide a different kind of incentive so that people aren't building in areas. We're certainly not going to stop the coast from evolving. The coast will evolve, and, you know, sand does move around. We spend an awful lot of money rebuilding beaches every year in Florida and places. I suspect that's going to continue, if nothing else, for recreational purposes, but it's not part of a more strategic investment in coastal flood protection of our critical infrastructure, and that seems to be where the debate needs to move.
Katie in Boston asks, if Boston was recently hit by Sandy, if we'd taken a direct hit, would you be able to put into perspective the damage that Boston would have endured in relation to the storm surges? What can and should we do to plan ahead and be prepared? Well,
if you talk about Boston, I think we might be singularly lucky. I mean, storm surge does depend on the nature of the storm. The tropical storm systems are unlikely to generate very large surge in the Boston area, just by virtue of the wind field and the path they can take. I mean, almost anything that comes directly to Boston is going to cut across Cape Cod first. So it's unlikely the tropical storm systems will produce the surge. I think probably the bigger risk is potentially with the nor'easters. But as far as I know, the largest storm surge in this area is the order of 3 or 4 feet. And I'm not even sure, that's predates my knowledge for sure, perhaps 1940s or something. But you add that to tidal range of 9 foot and so on. I don't think storm surge is the dominant worry for New England, or is not a dominant concern. New York is particularly vulnerable.
Because of how it's positioned on the
exactly.
coast.
It's got a bay which comes into it. The water is funneled into Manhattan, and it's an extraordinarily vulnerable location. Boston is not an extraordinarily vulnerable location for the storm surge. So we're somewhat lucky in that respect.
Yeah, that's really helpful, because I was having a conversation with someone else recently who's knowledgeable about this, and they were saying if we had taken a direct hit from Sandy and suffered a storm surge on the order of what New York had,
Oh yes, that would be catastrophic.
the entire MIT campus would have been underwater, or
Yeah,
most of it.
Yeah, I mean,
Yeah.
you would suffer that kind of damage, but I mean,
Yeah.
that is way beyond anything that I'm aware of historically in the area. I'm not an expert on the
Yeah,
surge modeling,
but it's unlikely.
It's unlikely. It hasn't happened as far as I know.
So Nicole asks, one option is to buy homes on the shorelines in imminent danger and maintain the shorelines for public recreational use with no structures. Hardened structures built to provide barrier protection from inundation have problems like erosion and habitat degradation and loss. Have you done an economic analysis to this effect?
Me personally, no. I mean, this is not something I do research on as a main part of my job, but let me try and assess there's various elements there. One part that she's talking about really is about trying to wind down national flood insurance. I mean, if you could wind down national flood insurance somehow, what she describes on buybacks and so on, and creating a barrier at the coast is all possible. So politically, that's the piece that's needed there. In the urban areas, yes, there's a lot of hardening things you can do. I mean, one of the most obvious things in Sandy was how the subways all flooded in Lower Manhattan for several weeks. And, you know, we have this bizarre situation where the subway entrance is at ground level and the ventilation is at the street level. And, you know, we've got a hole in the ground, which all you have to do is overtop the seawall at Battery Park and we will flood all the tunnels. I mean, it does strike me that one can build much more resilient infrastructure at relatively low incremental cost. So some of the things we can do in urban environments should be done. I'm not sure why they aren't being done. I don't know why our codes and our specs on these things haven't improved to reflect the risk. I mean, certainly we've had warnings on this. So there are things in urban areas we should be doing anyway, which are not all big ticket costs. I think that's what the question is driving at.
So I'm going to follow up a little bit on that. Are there ways that MIT alumni, faculty, experts get involved in that policy?
Well, yes. Actually, I was going to say, I don't know about so much on the MIT campus, for sure. I mean, we have a number of very prominent faculty who are involved. And Kerry Emanuel, I've mentioned, is very active in the forecasting and understanding of tropical storms. So there are faculty who are very actively involved. My involvement has largely been on the reviews of essentially the aftermath of Katrina and now on the Venice project, which is a fascinating experience, I must say. But the broader MIT alumni community, it's extraordinary. I've had several people write me who are involved in this broader policy debate. And, you know, so it's no doubt about it, MIT alumni and our network is very much engaged in this. I had at least one conversation with someone working for Mayor Bloomberg's commission and other people involved in writing op-ed pieces in prominent papers and so on. So the broader community is very active in this. And we do, of course, have a lot of work on coastal engineering at MIT, so there's quite a repository of expertise. But I think this is a debate which really takes far beyond the realm of the individual. It involves so many different aspects. I mean, from urban planning to the science of hurricanes. It's a lot of different communities around the campus who could be engaged.
So Dennis in Seattle asked a question which I think will give you a nice opportunity to tell us a little bit about the Venice project as well.
Yes, okay.
What kinds of infrastructural improvements can we take to lessen the impact of coastal flooding in high population cities? And so you might talk about your fascinating experience with Venice and
well, Venice, of course, is you know, undergoes. I mean, it is also a storm surge related phenomenon. I mean, there's tides and surge. The surge in Venice is actually from the Sirocco winds which come up the Adriatic. So everyone knows Venice has these regular flooding events. Sometimes they're at sort of catastrophic levels or near catastrophic levels. There was one early November this year where 2/3 of the city was underwater. The remarkable thing is how the city continues to function with these events. But Venice has a particularly unique location. It's in a lagoon with a couple of entrances, three main entrances. We've created to make it a fourth, I should say. But the environmental health of the lagoon is extremely important for the city, for its sewerage and everything else. There's also a massive amount of tourism and a massive amount of boat traffic coming through the lagoon. There's inshore fisheries. There's a large number of users of the lagoon. So the solution for flood protection for Venice is extraordinarily sensitive to all of those different participants. And it took a very long time to evolve, but it involves a really wonderful technological solution of mobile gates, which actually came from work done at MIT. I mean, you can track a lot of the design key contributions from work done in the hydrodynamics group in the Parsons lab at MIT, in my department, in fact. These gates are buoyant. They sit on the seabed. They're invisible most of the time, and when the surge is forecast, you pump air into them, and they're buoyant. They come up, and they act as a flapping gate barrier. This is the design. They're, you know, the Italian government is not flush with money at the moment, and so funding is a problem for them, a bit like the situation in New Orleans. But the construction is going on. It's a very large-scale project. The engineering is truly spectacular. It's some of the most sophisticated engineering you'll ever see, and so that's very exciting to me. And but I think our build-out time on this is now out to about 2016. So you know, there's going to likely be a few more flood events before we're through with that. But they're building essentially four big floating barrier systems.
So would a system like that work in, for instance, New York Harbor?
Potentially, yes, because the water depth is actually rather comparable to some of the deeper channels in Venice. So potentially, yes, but I think the design surge is a lot larger. I mean, 15 foot, I think the biggest surge in Venice is a fraction of that. So the scale in the open Atlantic is much larger.
Yeah, I was going to say, is that because of the shape of New York Harbor?
Well, you've got the big open Atlantic, a bit larger than the Adriatic.
Yeah.
I think that's the principal factor. So I suppose in principle, but I think the scale will probably require something more like the designs in the Netherlands, the Oosterschelde, the Eastern Schelde, or the Maasesklint, which is the mobile rotating gate barrier that's in Rotterdam. So probably something more like the Dutch system would be appropriate for New York, but it depends. I mean, there's been a variety of preliminary designs for New York. One of them involves a fairly large barrier system from, I think, Sandy Hook across to Far Rockaway, and there's other ones which are down near Staten Island and so on. I think it would depend which one of those systems exactly what the thing would look like.
How far out they go.
Yeah.
So Jarrell in New York City asks, how would FEMA approach revisions to floodplain elevations and other design requirements relevant to changing sea levels and storm surge magnitudes?
How would they approach it? I'm not sure I know.
I'm not sure I understand the question.
No, I'm not sure I understand the question either. I mean, you know, we do know the rate of sea level rise.
Yeah.
And, you know, FEMA will set its rates according to flood risk. So and beyond that, I don't quite know. I mean, they can adjust that. I mean, for example, in New Orleans, that's precisely what's happened after the hurricane protection system. You know, the assumption that goes into flood insurance for New Orleans now is obviously if you have a large enough storm, the system will be overtopped. There will be flooding in the city, and so there's obviously a calculation of where the most vulnerable parts of the city are, and that affects insurance premiums and so on, and it affects the elevation of houses inside the protection system. So
Brian in DC asks, could you speak to the potential social impacts of winding down flood insurance? Have these implications led to significant pushback?
Well, it hasn't happened. I mean, that's a simple answer. Yes, this is, I think, where the public policy debate ought to move towards. And obviously figuring out how to grandfather in, how to wind down that program or modify it. I'm not suggesting it has to go away, but I'm saying there's a lot of money going into it, which is inappropriate. It's providing the wrong set of incentives. You know, if we accept the fact that we can't protect all the coastline all the time, and the coastline will reshape, we've got to discourage people from taking risky actions. Better that we move towards private insurance systems where the premiums are sufficient that people are discouraged than having the government lose money by being a bad insurance agent. So,
and I think that's the political dimension. It's really hard because, you know, the people that live in Denver aren't particularly concerned about coastal erosion.
No, but they've got other flooding. In fact, you pick Denver, which after all is classically famous for flash flooding. I mean, there are plenty of flood insurance affects a lot of. That's probably why the program looks the way it does, because it affects everyone, inshore and off. It's not just coastal; it's flood insurance. Period.
Okay.
So it's floodplain development, and that actually may be the snag, is trying to decouple the different kinds of flooding risk. That may be an issue, yeah.
So William in Lobby 7.
Not so very far away.
Is this sort of megastorm the new normal?
Is it the new normal? I'm not the right person to answer that question. I think you want to get Kerry Emanuel back in here to answer that question. I don't know that it's true that it's the new normal. The mechanism to produce more intense storms is linked to sea surface temperatures for these tropical storms. So tropical storms originating in the equatorial regions of the Atlantic, there's definitely a possibility to increase intensity of storms. How much? And is this the new normal? I can't answer that question. That's one which you have to turn to the specialists. But
okay, so we're back to New York City now. Jonathan in New York City asks, does the St. Petersburg barrier in Russia seem appropriate to New York Harbor? Is St. Petersburg similar to New York from a storm surge perspective? Well, the Baltic isn't the Atlantic,
no, but
it's bigger than the Adriatic.
No, I was going to say that the St. Petersburg may actually be the closest analog to the New York City case, if you take the Sandy Hook barrier across to Rockaway. So I guess in that respect, yes. And I guess in terms of frequency of the flooding events and their impact on a large metropolitan area, I guess there are a lot closer similarities to St. Petersburg than to some of the other cases. Certainly to Venice, which floods more regularly with smaller surges. St. Petersburg, I think, is dealing with potentially catastrophic floods on the 10, 20-year basis. And that's why they started the barrier system. I was in St. Petersburg this summer, and it's kind of remarkable because they've only just finished the barrier. They started it in 1948.
Wow, that's a mega project.
Yeah, that's a mega. But it's a project which was clearly dropped at various points in its history.
Started, stopped. Yeah. So Greg in coastal Delaware asks, what is your view of the cost and effectiveness of the extensive beach replenishment projects the Army Corps has conducted over the past decade or so in the coastal barrier regions of New Jersey, Delaware, and Maryland? Is this an effective method of preserving the coastal towns and the recreational opportunities in these areas? Are there better methods of preservation that are affordable?
Again, this is not an area where I'm truly an expert, and I don't know what's happened in New Jersey and Delaware. There's a lot of money spent on replenishment. The Army Corps of Engineers has an awful lot of barges to move an awful lot of sand, and they seem to like to keep those machines active. It is truly preserving the environment of the beach environment, the recreational environment. It does that. Is it protecting those communities? Well, of course, if you put up some sort of barrier there, it does help. Is it cost effective? That's a question I would love to know. I don't know enough about what's spent on that. I haven't done research on it. But that's a question somebody should ask. And they should ask whether the federal taxpayer should be paying for it or whether it belongs as a local responsibility. I mean, that is clearly an issue. And who pays for some of these coastal communities?
Zandos at MIT asks,
that's a familiar name.
What are the geotechnical aspects and causes of the failures during the Katrina storm in New Orleans? Are there any similarities with the recent Sandy storm?
Well, the two are disconnected. In New Orleans, one of the sad things in Katrina was, if you look at the Katrina storm, the surge was very, very high on the eastern side of the city, in what's called St. Bernard Parish. And inevitably, all of the hurricane protection system that was there was going to be overtopped, and in fact, it was washed away. The sad thing of New Orleans is the immediate cause of flooding in the city itself comes from failures of storm walls on the canals emptying into Lake Pontchartrain. And those were engineering failures. And in fact, they not only created more flooding in the city than otherwise would have occurred, they also radically undermined the whole pumping system. They knocked out the pumping system, and it meant the city was underwater for 50 days, as opposed to perhaps 24 hours or 48 hours. And in fact, that is an area where I have done some research, because it's a very interesting question as to why those walls were under-designed. I mean, one of the challenges of engineering some of these systems over the time frame of tens of years is that people lose track of the story. They lose track of the key details. So you really got a sense in New Orleans that although the system was authorized in 1992, it was not built as an integral entity. So no one had an overview of all the details, all the technical specs on the levee.
As you go along, I have to imagine that the state of the art of engineering also advances,
right.
And so you might go back and retrofit something. Or
right, and then of course what we've been talking about is that the risk has changed. I mean, if you take New Orleans in 1970s when all this was being planned, and you look at it today, the coastal erosion in southeast Louisiana is truly epic. And I don't think beach replenishment would fix that. In fact, in southeast Louisiana, it's a combination of factors. It's subsidence, and that's partly due to oil and gas extraction. It's also geological subsidence. It's a fact that the channeling of the Mississippi River stops the replenishment and sedimentation. So there are many other factors that are specific to southeast Louisiana, which also aided and abetted Katrina's storm surge, if you like.
Yeah.
I mean, there were barrier islands that existed in the 1970s that were washed away.
That are gone.
long before Katrina came along. So, so the environment itself has changed. I mean, in other words, the coastline is changing, and the risk therefore changes.
So the project needs to be re-engineered.
Yeah, exactly, and trying to keep up with that. And to update that. And that's a challenge for everybody. I mean, the Dutch government recently looked at sea level rise issues for them, and the Dutch have always taken a view that they should have very, very low risk of coastal flooding, like a 1 in 10,000 year event, which is almost an absurd time period. But their analysis is they want to be a very extreme case. They look at sea level rise and they say, well, of course, our risk is going down. You know, the time frame is going down. So what do? We have to upgrade our system. But they've now put a price tag on upgrading the system to achieve what they had hoped to achieve in the 1970s. And that price tag, I don't quote, well, you can quote me on this. It was, I think it was a couple of years ago, and I think the price tag was like $800 billion. It was such a large sum of money that the Dutch government is seriously thinking maybe 10,000 years wasn't the right number. Maybe it should be 1,000. But you know, that's the kind of problem they're in. But it is a problem of upgrading, and sea level rise is certainly affecting existing systems and asking people, have we still got the same protection level?
So as we conclude, is there anything else you would like to share with the MIT community about your work in this topic?
I think we've covered a lot of different issues.
We have covered some coastline there.
I think that's a very good way to describe it. Thank you.
On behalf of the MIT Alumni Association, thank you very much, Andrew, for being with us today. And thank you to our viewing audience for your participation. Please continue to discuss these topics on our Slice of MIT blog. This is the last of the faculty forums online for this calendar year. Please join us again in early February when we will resume this series of chats with MIT faculty.